Okay. So good evening, everyone. Although we have just, okay. So today we are going to be looking at Pandas part 2. And then we are then going to explore the data a little. So next week, what we are going to do is that we are going to use that same data for a machine learning problem. So today what we'll do is that we'll just explore the data and see what the data is all about. So let me share my screen. Let's share screen. Okay. Okay, so I believe you can see this Titanic. Okay, so I'll bump it up a little. Again, I'm on Colab, and then, so Titanic is a very popular data set in machine learning, in Pandas. It came as a result of, I think there was a ship that was on voyage, was it in 1915 or so? And then the ship was termed to be like it was termed to be, should I say, perfect, until when it was then launched, it then had a crash. So I got this data from Cargo, and like I said before, there are many ways you can get data. So you just have to know how to get it. Now, Cargo has an API that you can actually get data from without necessarily downloading it. I'll share the link about how to get the API in the group. But for today, let's just go to Cargo and then go to Titanic to show you how I got the data. So, okay, now, can you see this other screen I'm showing here on Google? Is it visible?
Yes, I can. You're live.
Okay. So it's a very popular data set. And what I did was that I just typed in Cargo Titanic data set download. So I'll go to the second option and click on it. Now, it was designed in the form of a machine learning problem. So you see that you have your train CSV, test CSV, gender submission CSV. So a quick understanding of what this is that you take the training CSV and then work on it. So you develop a model using this train CSV. Then you test your model to see how good it actually is using the test CSV. And then you submit your results with gender submission CSV. This is what we'll do next week. But for this week, we'll be looking at the data exploration aspect of it. So before you can download, you have to actually register on Cargo. I don't think it's a difficult process. It's just to put in your email, verify your email, and then you'll be registered on Cargo. So I'm already registered. That's why I'm here. Now, this is a competition. This one, it's a competition that has been here for a while. This 4 years. You can actually take part in the competition by clicking on late submission. So if I click on late submission, you see, I understand, I accept. I don't want to join the competition. But maybe that's what we'll do. Now, coming down to what we want, I want to show you how we can download the data. So over here, Cargo competitions download at the bottom right here. If you have the API, you can just copy this and download it directly into your notebook. So like I said, or the Cargo credentials rather, I'll drop the link as to how to use this Cargo Cargo credentials to get data. But what we are going to do is that we are going to download the data from here. I already have it, but if you want to download, you come over here. So you have this download button and you click on it. It gets downloaded. I've downloaded it before. I'll not download again. you come to the what's this down the right hand side. So this is you click on it and you download. You can download individually, or you come down here and download all. So you have to make sure that you either download gender, Titanic test, and Titanic train individually, or you click here and download all. Now, like I said, I've already downloaded it, so I will not download again. Coming back to my notebook. So again, one thing you need to do is that you need to actually understand your data before you start working on it. So usually when you are given a data science problem, you are given a description of the data sets and the goals that you need to that's your goal. So if you see here in the file descriptions, you have here the training sets, the test set, the gender submission. So a sample submission file in the correct format, male is 0 and female is 1. So this is very important, that your male is 0 and your female is 1. Okay, because in machine learning or in computer in general, we don't usually deal with text data. You have to convert it in some form of machine language that the computer can understand. So even if I'm giving something in textual form, I have to think about a way of converting that data to numeric form. Okay, so this one didn't give a good description like I want. I would go to another link. I want to see a description of the data. So let me go to this top one and then read. Good. So this one gives a good description of what the data is. So it says the training set should be used to build your machine learning models. For the training set, you should provide the outcome, or we provide the outcome and the ground truth, blah, blah, blah. So look at the data dictionary. So this is something you should look out for when you are giving data. Don't just, when you are giving data, you just start analyzing. You need to first understand what you are doing. So I'll come to this data dictionary. Now you see, in a data dictionary, you are giving the variables and their definitions or what they mean. Now, so you see here, survival, we are going to, what this means is that in this data, we have columns that are survival, P class, sex, and all of this. So it says that for variable, the definition is for variable survival, it simply means survival. And the key 0 means no, that means this person died. And 1 means yes, that means, sorry, no means the person did not die, and 1 means the person died. Then P class, you know, in a ship or boardings, things that have to do with transportation, sometimes you have different classes. So in this case, you have P class simply means the ticket class. So first 1 means first class, 2 means second class, and 3 means third class. And of course, we have the sex, we have the age. Now notice that in this one, they didn't specify whether the sex 0 is male or 1 is female or anything of that nature. And if we look at this competition, it's still ongoing. So it's like a competition that Kaggle has organized that doesn't have like a deadline, that you can continue on and on and on. So we have SIBSP, which is siblings or spouses aboard the Titanic. The patch means the parents or children aboard. Tickets, the ticket number. Fare, the passenger fare. Cabin, the cabin number. Embarked, port of embarkation. That means where the person took the ship. So you can see again variable notes. First means upper, second means middle, and third means lower. So one thing that you have to always remember is that whenever you are giving data, if you are not giving information about what the data is, you have to ask, what is the key? What does each variable in the in my data sets mean? Now, so Kaggle even went ahead to give a sort of descriptive statistics about some of the things in the file. So you see the passenger ID and then the survival rates. So if you come here, this in the compact form, this in the detailed form, this in column form, which this one I think is more bigger or more visible. Okay, so that's that for this. And again, you can download by clicking on download all. So let me just pretend as if I've not downloaded this before and click on download all. So what it does is that, I don't know if you can see this, but down below, it's downloaded as a zip file in my computer. So if you download all together, it will download as a zip file. But if you download individually, it will download as CSV file. So I'll come back to my Colab, and then I have to unzip the file to use it. Okay, so first of all, when you are doing data science, I think one of the 3 libraries you make use of are Pandas, NumPy, Matplotlib. So even if you don't know whether you use it or not, just put import Pandas as PD, import NumPy, as NP, then you import matplotlib.pyplots as PLT, right? So remember that if you don't have any of these libraries installed before, you can install them by doing pip install, then the name of the library. So if you don't have Pandas before, you do pip install Pandas. If you don't have NumPy before, you do pip install NumPy. If you don't have Matplotlib, you do pip install Matplotlib. Okay, so and then you run it. So for me, I've already installed them. So it's telling me that requirements already satisfied, pip is already satisfied. So this is not useful. And then when you are done, you can comment them. Okay, so this me importing all of these things. Now remember that I downloaded this as a zip file. So what I would do, like we did last week, I'll come, if I'm using Colab, I'll come over here and then click on it. Then I'll click on this arrow up here, and then I'll go to my downloads folder. I noticed that last week, you people could not see what I was showing in my computer, but it's fine. You know how to identify the file. So the main thing is just to identify the file that you are downloading. Now, so this is the Titanic zip data here. Now, we can't use this zip data. We have to unzip it. To unzip it, you copy the parts. So it applies the same way on your local computer. You have to be able to understand how to read the parts as to where a document is. So maybe next week, I'll do everything locally instead of doing it on Colab, so that we can understand how to read parts and to read files. Now, I'll come to Titanic and then copy parts. Now, to unzip on Colab, you would put your, what's this thing called now? The exclamation, and then say unzip. Now, if I want it to be an unzip that, okay, let's just have it this way. So unzip, and then I'll put the name of the file, and then I'll run this. Now, so because I already, let me stop this and start again. Why this one is asking me this is because I already have it in my, I was doing this before the start of class. So what I'll do is that I want to delete, disconnect and delete one time. So if you are watching this and you've not done this before, you don't need to do that step. Why I'm doing it is because I want you to actually know how this thing is being unzipped. So it means I have to reconnect again. I'll come over here at the top right, click on reconnect, and then after reconnecting, I'll then start all over again. It means that now if you come here, you see that nothing is here again because I started all over again. Then again, I'll run my libraries, and then when it's done, I'll come over here again. So you see, because I disconnected by runtime, all the files I disconnected and deleted, all the files I had here before are no longer there. So I'll upload again. Last week, we saw how to upload from Google Drive. So today we are uploading locally. Now, this then the file here is not heavy. That's why we have it so fast. Again, I'll copy the path. It will still be the same path, but let me just pretend as if I don't know it's the same path. Let me delete this, and then I'll do unzip, then the name of the file. Okay, so sometimes you may need to put this. If, for example, you have spaces between the words, so actually it's good practice to just put it within quotations just to be sure. So now you see that it has inflated all of these things. And then we have the gender, submission CSV, test, and train CSV. Now, if I come over here to my files, you see I have these things here, which I just unzipped. Now, in today's class, we'll concentrate on train.csv, and then next week, we are going to look at test and submission CSV. So train.csv, now, just like we did last time, we would need to read our data frame first. So I'll copy the parts, and after copying the parts, I'll give this a name and say PD. Remember to read a data frame. You say pd.data frame, and then the name of the file. So data is capital D and F is capital F, and we'll do df.head. Okay. Now, sorry, I'm supposed to say pd.read CSV. So pd.read CSV, and then you get the name, and then you put the parts, and then the head. Now, what do we see? We see our data frame here. So we can start exploring. Now we have the passenger ID, survived, P class. We've already looked at what each of these things are. And remember that at the start, I said that when we are dealing with machine learning or things related to the computer, it cannot really understand text. So at some point, there needs to be some form of conversion to codes that, or to a language the computer can understand, that can read. So there would be a time we have to convert whatever we have to a numeric value. Okay, so let's first have a feel of what the data is like. And when I'm giving data, one of the first things I do is to do a df.describe. This gives an overview of what the data is about. So I have my passenger ID, the counts. So it gives a sort of descriptive statistics. Is that the word? It gives statistics of what this is. So I know my standard deviation, I know the mean, and all the information which is needed. Now, after doing a df.describe, one other thing is to do a df.info, which gives you information about the data. Why is this important? It's important because sometimes you might see that, for example, you have in this place where we have 313. Normally, you think that this is an integer value, but depending on how the data is entered, it can actually happen that this data is not even integer, but a string. So having a look at my data will give me an idea of what each of the variables, the type of each of the variables. So I see here that I have my passenger ID as an integer, the survived as an integer, which it should be, the class, which is an integer, name, sex, age, and all of that. So coming back to this, so this is what we are trying to do is exploring the data and to find out interesting things about the data. So one of the things we can actually do is to find out what each of these things, like how many unique values are in each of them, in each of the columns. So sometimes the number of columns you have could be large. You could say df.columns to know the columns you have, and it's a good practice to know the shape of your data. So how large is my data? df.shape. So this is like maybe the hello world of pandas to do a describe and info column and shape. Okay, so moving further, we can go ahead to get a feel of what each of the individual columns are. So there's a function called the f dot. So I could pick a column, and then so maybe I want to pick the column age. So I want to find out, for example, how many what's the age distribution like in my data. So I can actually say number of unique, first of all, to find out how many unique values I have. So it means I have 88 unique values. I can also go ahead to say this same age and find out what these 88 unique values, what are they? I can do a value count, df dot value count. And then when I do df age dot value count, this is quite huge, but we can actually see the distribution of the data. Okay, now, so what I want us to do today is to look at some functions, should I say some functions or some methods that are important. So we'll be looking at how do I apply a function across a column. So we'll also be looking at the apply method, the apply map method, and then the map method. We'll also be looking at, I think I have them here. So group by, I hope we'll have time to go through all of this. And we'll take a look at some few plots, and then we'll see how to fill missing values. Okay. So okay, let me just go through what I've done so that I don't. So there is a function called drop duplicate. So in machine learning, we don't usually like duplicate values. So we would like to drop duplicate rows that are duplicates. We don't want them. So the method we use to do that is to say df.drop duplicates. Now, if you want these duplicates to be dropped and like it should continue, we use the in place equal to true to say, okay, drop it, like drop it and really drop it. I don't know why this thing doesn't. So to say in place equal to true, and then, okay, I was actually supposed to check if they were duplicates first. So let me go back and do this again. Okay, so I think there's a df dot number of duplicates, right? Let me see. I think it's duplicates. I've forgotten the, wait, check if they are duplicates. So I want to check how to check if they are duplicate rules. So it's dot duplicated. So I'll say df dot duplicated. Okay. So I think dot sum. So 0. Now what this means is that it's telling us that there is no duplicates, or there are no duplicates, right? So if, for example, they are duplicates, and another way to also know whether they are duplicates or not is to check the shape before and after duplicates. So after dropping duplicates. Now, in this case, when we did the f dot shape, it was 891,12. That means we have 891 rows and 12 columns. So if I still apply the function and I say df dot drop duplicates, and then I say in place equal to true. So if I run this, what it means is that it has dropped the duplicate. So if I want to know whether the any duplicate has been dropped, I can just check the shape of the data. So it remains the same thing as we had before. So it then validates that there's no duplicating our data frame. Okay, so after doing this, we would go on to look at what we have here. Function. Now we've done functions before. So what a function does is that it helps us to sort of avoid repetition. So instead of me doing one thing over and over again, I can just write a function that can like do that thing at a time at one point. So before that, let me explain, for example, if I want to add a new column, because sometimes you might be interested in adding a new column in what you are doing. So I have here passenger ID, I have survived, I have P class, I have name, I have age, and all of this. So for example, let's say I want to add another column. Remember, I started at the beginning by saying that in computer science or in machine learning, we usually want our data to be in some numeric form and not textual form. So we do a sort of conversion. So here in my sex, I have male and female, and I can actually validate that by again doing my df, then calling the name of the column and saying df sex, and I can say dot value count. And I'll do dot value counts. So when I run this, it shows that I have male and female, 577 male and 314 female. So what if I want to convert this thing to numeric form? There are several ways we can accomplish this, and one of it is using an if function, or to say, okay, if the value is a male, we can decide. Now, they didn't tell us what it is, but we can decide to say we are giving male 0. Let's go back to this Titanic and see if they specified whether male is 0 or female is 1. So sex. So we see here that it was not specified. A set of predictions that assume, okay. So it says that in the gender submission CSV, a set of predictions that assume all and only female passengers survive as an example of what a. So now, from Kaggle is telling us that the submission CSV assumes that all female passengers survive, but it doesn't tell us what female passengers are. So one way we can be able to understand what that means is to go to our gender submission CSV and read it. So again, I'll copy the parts, and then just like we did before, we'll do a pd.read CSV, and then put in the part of the data and say sub.head. So I want to understand remember they said that all the females survive. Now, we then have zeros and one. And from what we have here in the survival, it says survival 0 means no and 1 means yes. So it means, again, we have to then think about, and this is the ID. So IDs are unique values. We need to think about what probably 0 is and what 1 is. So we can actually guess. So one way to guess, if we look at the distribution of our data in our what's this called? In our training set, we see that male is more than the female. So male is 577 and female is 314. So we can be able to decide to say, okay, we'll give, since in our training data we have more male than female, we can decide to give the higher number of the survived as our male and then the other as the female. So what I'll do again is that I'll do sub, then I'll say survived dot value counts. Now, so when I do a value count, I see that 0 is 266. So it's most likely that this 0 are male, because from the training data, we have male as more than the female. So I'm only speculating. There's nothing that says, oh, I'm not sure about what I'm saying, but looking at the distribution, if the train has more male than female, it's most likely that the submission will have more male than female. So I can decide to go by this. Now, in this competition, what happens is that you continue to submit predictions, and then there's what you call a leaderboard. So after you submit, you see your score on the leaderboard, and then looking at the scores on the leaderboard, you may be able to, I said May would come next week, we'll discuss more about it. You may be able to tell whether your decision to take 0 as male or 1 as female is actually correct. But it's not entirely, you can't entirely say because you have a high score here, it means your assumption is correct, but that could actually serve as a good background. Okay, so coming back here, it means that what I will do is that I'll give 0 to male and 1 to female based on my analogy, right? Which might be wrong, but I'm hoping that is correct. Okay, so where was I? I think I was here. Okay, so coming here, okay. Now, I would do this in 2 ways. I would use a lambda function, and then I'll use an if statement in a function to try to allocate new values. That is to try to, they call it encoding, label encoding. So whenever you take a category, and these values that we have, male and female, they are called categorical variables. So, or categorical values. So if I take categorical values or categorical, so the column is a categorical column, right? So if I take that value and convert it to being numerical, so it's referred to as encoding. So it's like we are encoding it in some other way. Okay, so let's say I want to replace 0 and 1, and I want to use another column for it. So I can create a new column and say maybe my column is DF. Let's say the name of the column is gender. So it means that whenever I want to create a new column, I should call the name of the data frame and the name of my new column. So if that column does not exist, it creates a new column. But if the column already exists, it replaces the column that was there previously. So I don't know if I'm going ahead of myself, but I would use an apply function to say I want to apply on this df.gender. What I want to do is that I want to replace zeros with one. So remember that this is from sex. So I'll say df sex. Then I'll now use an apply to say I'm applying a function. And remember I said it's a lambda function. So I'll say lambda. And then you would have to give a name. So I'll have to give a variable name. So I can call it X. So what this X means is that it stands for this our column, lambda X. So I can say lambda X. And remember that I want to say that if it is a male, then it should be replaced by 0. And if it is a female, it will be replaced by 1. So what I'll do is that I'll say lambda X and then write a simple if statement. So it's like you're doing an if within lambda. So I'll say 0 if X is equal to male, and then else it should be 1, right? So what this means is take your sex column and apply this function. So this X is sort of standing like a variable, and see, with respect to what I'm doing, if X stands for male, then assign 0 to it. So if X is 0, if X is male, I assign 0 to it, else assign 1. Now, so when I run this, now let me now look at my data frame now and say df.head. So let's look at the end of the data frame. Can we see the gender here? The gender is just here. And you can see it replaces 0. If I have here that I have male, I have 0. Here I have female, I have 1, right? So in fact, we can actually see it more clearly by just taking only those two together. So I just want to see only the sex and then the gender. And then I run this. So you see male 0, female 1, and all of that. So there, aside from this if statement in a function, we can still use np.where to write a function. And then actually, there are a lot of ways you can do the same thing, a lot of ways. So in this case, I created a new column and named it gender. In this ifs, the second way I want to do it, if statement in a function, what I want to do is that I want to replace the sex column entirely by zeros and 1. So first of all, I'll define a function. And so maybe I'll name my function label encoding, right? And then it takes a data frame. So again, I can just use a return. I hope this works. I'll say a return 0. So let me copy this same code because it's still, it can still work. Or I can say if the F is equal to male, remember we are in a function, so we have to return in order to get a value. So I'll say return 1, then, sorry, return 0, else return 1. Okay, so this is my function. Now I want to apply it over the F6. So now remember that in this other one, I created a new column, gender. Now I don't want to create a new column. I want it to replace that column that's where the sex is. So I'll say sex. So I'll just be like label encoding. And then I'll cut this, put this here equal to 6. And then when I run this, okay, we have a problem. Okay. So what I'll do is that I'll use the apply method to do this. So I'm going to say the F6 dot apply. And then I'll call this label encoding. Oh, this one. Okay, so we are having the same issue. Okay, I'll look at this. I'll look at how we can go around this using the apply method. But it should work. I'll look at how we can go around this using a function. Okay, so let's move away from this one and then go on to. So this other function is a function where we have, just like we did this one in this last one, though this one is not working. I think this one we could do .any and see if it will work. Or .all. Okay, so I'll look at this later. Okay, so this same thing that we did, I did a function that is called .number of unique. So what we've been doing previously is that we've been checking the number of unique, like we've been looking at it one after the other. So what if I want to actually, like here, what we did was that we picked just one value and checked how many unique values are there. But what if I want to check for a whole lot? So that's where the function comes to play. And then again, yes. So that's where the function comes to play. So I named it define as number of unique. Let's say number of unique. And then I give my data frame. And what it does is that it simply returns the f.number of unique. So running this function, it means I can just take the function and then find the number of unique values I have in my data frame. I missed an N here. Okay, so here in the passenger ID is 891, survived is 2 and all of that. So what this means is that the passenger ID is actually a unique value for each of the people on the ship. So this will be very important when we come to our prediction. We then have the survive, which is, of course, is just two values. Okay. So one other thing we would like to look at is how many null values are there in the data frame, because you would need to replace null values by maybe mean, median, or whatsoever you want to, depending on the question at hand. So if I say df dot is any dot sum, what this does is that it gives me all the sum of each column, the number of missing values. So all of these are not missing except age and cabin. So one thing we can do is to study the distribution of the age in the data and then decide, should I allocate, because age will be very important. You don't want to throw it away, but this cabin, the number of missing values are quite high, so we can actually decide to remove this column. You have just 891 data rows and you are having 687 that are missing. It might actually be better for you to remove it, except of course you find a very good way of replacing the null values. So for age, we can now think about how we can replace the ages that are missing. So coming back to where we were at the beginning, we see that for age, the mean of our age is 29.6. The standard deviation is 14.5. The minimum age is 0.4. So, and 25% at this age, 50% this, and the maximum is 80. Now, for machine learning problems, you can actually play around as well with different values and see what possibly they can give to you. But before we go to replacing the null values, let me just quickly talk about the apply map, and then the map. Where is it? Yes. So I've spoke a bit about adding new columns. So if you want to add new columns, just call the name of the data frame and then the name of the new column you want to name. So what apply is that I've used this one at the top where I did the apply function. So you apply a method column-wise or row-wise in a data frame, which we did somewhere here. Yes. So we use the apply function to say lambda x if x is male, else 1. Now for the apply map is used to apply a function or a method element-wise. That means you apply it across all the values, elements by element. And then the map is to apply a method to a series. So when we talk about a series, we are talking about a single column in of a data frame. So a single column is a series, and then when it's more than one, it's a data frame. So what this means is that I can only use map when I'm dealing with a series. If I try to apply a map function or a method or a map method within a data frame, I'm going to have an error. So we have looked at the apply already. Let's see how to look at the apply map. Now, remember in our data frame, we have a mixture of both numeric values and categorical or non-numeric values. Now, sometimes you might be interested in selecting a subset of your data, and there are different ways with which you can do that. You can actually group all columns like we did here. I think we've done it before. Yes, so here that I just grouped gender and sex together. So this is a way of selecting a subset of your data. So you might actually be interested in selecting your data based on the data type. So for example, remember that we are trying to use the apply map. So maybe I say DF and I want to select all, numerical values. So I can do this df.select the types number. So there are different other methods you can use to select just numeric values. This is just one of them. So what this does is that it gives you, because passenger ID is numeric, it gives you, it's part of it, survive, P class, and all of that. Now, but if I'm applying a function, I don't want to apply to what's this now? To passenger ID. Why? Because this is the ID column. Now I can decide to drop the column. There are different ways you can drop. You can again select a subset and maybe give this thing to say dot columns. So these are column. Now, if I don't want passenger ID to be part of it, I can actually get all the column names and say, maybe I name this numerical data frame, and I say I'm selecting the F, and I'm putting all of this except the passenger ID, and I can do df this dot head. Okay, so we see that that one is gone, right? Now, while we're doing this, we are trying to use the apply map function. So using the apply map function, I can call this and I can say dot apply map. So maybe I want to do a function that will sort of multiply every value I have by something. So the lambda function actually comes handy. And just like we did before, we can say lambda x, and we can just multiply. Maybe I'm saying x times 2. This is what my function, my apply map function is. So what did it do? It's multiplied each and every one of the values in our numerical data frame by 2. So that's just what the apply map does. So it does it a sort of element-wise operation across all the values that you have. Okay. So the next one will be the map. Now, so if in this one we have, so maybe I want to do a map, I'll just still copy the same thing and paste it here, and instead of apply map, I'll do a map. Now what do you see? It says data frame object has no attributes map. So what this means is that, remember I said that a series is just one column and then a data frame is 2 or more. But if I just specify only one and I say I'm interested in the age and I use the map function over it, we see that we don't have an error because the map only works on a series. Series, just one column. Okay, so I think we are done with this. We are already past the time. I'll just quickly talk about this one. So a group by, what group by does is that it's just like the word group, it groups by a certain column. So here we are telling, we'll call the name of the data frame and put the group by method, and you're saying group by. So for example, I can decide to group by survived. So if I just do this without putting this, what happens is that it returns it returns something to say this is a method, right? Now, this stuff here is like an aggregator. So whenever I'm using a group by, I have to specify my aggregator. How do I want to aggregate the values? So I'm grouping by survived. So what would be my aggregator? So you can think about an aggregator as a way of summarizing your data, because what the group by even actually does is to give a sort of summary on different levels. So I group by survive, and then I summed it up. So what it does is that it takes it separates the data into survived, so 0 and 1. So all the IDs under zeros are summed together. All the IDs under 1 are summed together. Not only can I do a sum, I can do a count. So there are different aggregators depending on what you are doing. I could do a size, right? So you can look up the meaning of what each of these are, or what each of them mean. I can do a mean, and so on. So what if I want to group by more than one column? I can always do that. So here I'm grouping by survived and sex. So you can see it first of all divided the data into two parts, survived and zeros and 1. Then under sex is divided it into two parts again. Then by specifying this, I'm saying I'm only concerned about the fair column. And then what it then did is that it then took my aggregator, in this case is sum, and then it summed the values. So grouping by survived and sex. So the same thing here, we group by count, but in this case, the only difference is that I renamed the axis. So before it was survived and sex, by putting dot rename axis, we are renaming the axis of our resultant frame. Okay, so we then have the plots. So I can plot. So when I take the size of it, like I'm taking account of what they are. Now we can see that you can plot by, again, you have to use your aggregator, and then this is a bar plot. So we just do dot plot kind equal to bar, and then this is a pie chart. You do a group by, your aggregator specify the kind of plot you want to do. So Y is now saying that, so this is survival rates by sex. So we are looking at people that survive based on their sex. This auto PCT says the number of significant figures. So we see here that is one significant figure. So if I want more, or if I want just 0, I can just change to 0. And then the colors, if you like, you can remove it and don't put any color. It will take the default color. And then I have the title, survival rate by sex. So lastly, for filling missing values, we can use the fill any method. So there are different ways you can fill. You can forward fill, backward fill. Forward fill means that fill everything, like you should fill based on what is in front of it. Backward fill, what is behind the missing value. So this one is a fill by the mean. Like I mentioned at the beginning, you calculate the mean of the age, and then you then just fill the missing values by the mean. So in place equal to true, anytime you say in place equal to true, what it means is that they are ensuring that that thing is there and it remains there even after you are gone from that cell. So I think that's for what we have today. I'll share the notebook, and then anybody that has any question can ask me. What we'll be doing next week is going into data science proper. So we'll start with a classification problem, and then yes, a lot of information to absorb. That's true. So we'll be starting with a classification problem, although typically most people start with a regression. Would actually look at what regression and classification mean. Then we'll go ahead to look at how to actually implement them. So thank you so much for being here. I'll stop sharing.